the variable medv. Then we set the x label medv and the y label count. So let's bring or let's show, and we have here the this is now the illustration, the histogram of medv. So a histogram represents the frequencies of all x values with a series of vertical connected bars. So the histogram represents again the frequencies of all x values. Here our x value is the med v with a series of vertical connected bars. It's which is the count. So in this example histogram that we made, um, there are over 150 tracks where the median value is between 20K and 25K, or $20,000 and $25,000. So note that the MED values are in thousands. Okay, so that's 20,000, between 20,000 and 25,000. There are over 150 tracks. So next is another way to make histograms is to show the grid lines behind the histogram. So this is just the same histogram, but the layout is it does not show the grid lines. So the grid lines are behind the histogram. So let's add another code cell for the box plot. So to create a box plot, you have this code for script. We create another AX for our box plot with column medv and the chas. And then the Y label is medv, the subtitle and the title, blank subtitle, and title is also blank. So we have this result. So again, a box plot that represents the variable being plotted on the y-axis. Although the plot can potentially be turned in a 90-degree angle so that the boxes are parallel to the x-axis. So there are two box plots here. This is called a side-by-side box plot. So the box encloses 50% of the data. For example, in the right-hand box, half of the tracts have median values between $20,000 and $33,000. The horizontal line inside the box represents the median, or we also call it, the median is also known as 50th percentile. The top and the bottom of the box represent the 75th and 25th percentiles respectively, and the lines extending above and below the box cover the rest of the data ranges. Outliers may be depicted as points or circles. Sometimes the average is marked by a plus or similar sign. Comparing the average and the median helps in assessing how skewed the data are. Box plots are often arranged in a series with a different plot for each of the various values of the second variable, shown on the x-axis. So if you're not, I will not go into detail more about box plots, so you can just uh, search about it, what is a box plot, and that's actually in maybe if you encountered it in your basic statistics, then you know that the box plot shows the median, the 50th percentile, the 75th and 25th percentile of the data. So because histograms and box plots are geared toward numerical variables, their basic form is useful for prediction tasks. So box plots can also support unsupervised learning by displaying relationships between a numerical variable, the y-axis, and a categorical variable, or the x-axis. So if we look again at the histogram, yeah, we're going back to our box plot. We can see here there are circles here at the zero, or the chassis category is zero. You can see this zeros or circles here indicate that these are outliers, meaning that these values are somewhat different from the data, from the normal data of our data set. This can be a signal for more interpretation and for for uh, for more, or this data can or these outliers